Well, now that you know everything there is to know about slopes, we're going to use them in the equations of lines. There are two main types of line equations. There's the slope-intercept form, written this way: y equals mx plus b. Why is it called slope-intercept? Well, if you were to graph it, the slope right here, that's m. The y-intercept, that's b. Hence, slope-intercept. For instance, if I wrote 3x plus 1, that tells you it has a slope of 3 and intercepts the y-axis at the point 1. Cuts across there at 1. That's slope-intercept. I guess I could write it here. Slope-intercept. That's this. Now, what else have we got? Well, we could write it a little bit differently. Suppose we wrote ax plus by equals c. What's that? That's also a line. It's another way to write it, and this is called standard form. I don't know why it's called standard, because if you ask me, this is way more standard. If you want to graph an equation, you normally put it in this form. That way you've got your x versus y all laid out for you, and you can start plotting points. This is also called, and this is the term I use more often, but I'll try to remember to say standard in this course, is implicit. X and y are implicitly defined. Neither one is explicitly defined in terms of the other. We don't have, in other words, an equation or a function that says x is equal to a bunch of stuff on the other side with a y in it, or y is equal to a bunch of stuff with an x in it. We've got them all mixed up together. That's called standard or implicit. I think standard is probably what they use it most of the time in this course. But if you hear the word implicit, that's what they're talking about, is this here. Well, now that you know both equations for lines, I guess we're done. Well, you're already experts on slopes now. You know everything there is to know about slopes, so we're going to use them to write equations of lines. Suppose we want to write an equation for this line. Well, looks to me like we already know the y-intercept right here. It's 0, so boom. B equals 0. We got that. So what we need to find is m. We don't know what that is, but we know how to find it, don't we? Oh, let's take this as P2 and this is P1. So we have 0 minus a minus 4 all over 3 minus 0. So that's 4 over 3. And that's m. So our equation for the line is y equals 4/3 m plus 0, which is just 4/3 m. Pardon me. So here we have one of those find the error problems. The bonehead instructor made a mistake here and got the equation of the line is equal to 4/3, and that should of course be an x. If you get the impression I'm kind of tired, I suppose you're right. Don't know what the problem is. I slept like a baby last night. Cried and went to bed. B here, the y-intercept, it's not 0. What kind of a dope would say it was 0? Well, one like me, I guess. the y-intercept is minus 4. 1, 2, 3, 4. Minus 4. It's not the x-intercept that we want. It's the y-intercept. The only thing you have to remember about the slope-intercept formula is that it refers to the y-intercept. And I reversed it. So that's 4/3 x plus a minus 4. Or if we write that so that a normal human being could write it, or read it rather, how about we just wrote 4/3 x minus 4. That's the equation for the line. Those of you who are paying close attention were probably screaming, "That's not the y-intercept. What's the matter with you?" Well, you were right. Hope you didn't hurt the eardrums of the people next to you. Now here's where we make use of what the slope-intercept form means. mx plus b. M, part right in front of the x, that's the slope. B, that's the y-intercept. So, where's the y-intercept on this one? It's at the point 1. So, we know that for this one, b equals 1. That means one of these two must be right, because over here, they say that the y-intercept is 0. And it doesn't look that way to me. Now, what about this here? This point is on it. And this point over here, which looks like 2, 0 to me. Though we could just count if we wanted to. The rise, it's 2. Why don't they write a minus 2 there? Well, anyway, the rise is 2. Oh, I see what they mean. Yes. It drops 2, it doesn't go up 2. Thank you, guys. And over here, the run, well, it looks like it's supposed to be 4. And that looks like a positive 4 to me. So that's minus 1/2. Do either one of these have a slope of minus 1? Oh, yeah, there it is. This would have to be the one. Boom. You didn't even have to go through the rigmarole of finding the actual equation. And I would do lots of multiple choice problems like that. Try to find a way to toss out one or more of the choices. And just keep doing that. You toss these out because you knew b couldn't be 0. And you could throw this one out because the slope isn't minus 2. And that leaves you with that. We know the slope is 3. Now we're going to start plugging things in to find b. Just set it right up here. What is y? We know it's minus 2 for one point on the line. And that is the point where x equals 6. So we have 3 times 6. 3 is our slope. Plus b. Well, minus 2 equals 18 plus b. I think that leads to b equals 16. So we put a 16 down here, that's our b. And that's our equation for the line. Does it make sense? Well, it better, because we use this we use the fact that it makes sense to solve this equation. In other words, if I plug a 6 in here, then v would equal minus 20. Subtract 18 from each side and get minus 20. So this right here, 3x minus 20. If I was better at arithmetic, this would go so much more smoothly. You know, Einstein said he wished he was better at math. I wish I was better at just about everything. Here's one that's the only trick. This is just like the last one we did. We're we can find an equation of a line that passes through a given point here with a slope that we don't know yet. We just want it to be parallel to this line, which has a slope. We have the equation for the line. Unfortunately, it's in standard or implicit form. To get the slope, we'll have to put it in Slope-Intercept Form, which in this case is pretty easy. We can just do it up here. First thing we do is add x to each side and write 2y equals 12 plus x. Now we divide through by 2 and get that y equals 6 plus x over 2, or 1/2 x. Now this part here, for what we're doing, doesn't really matter right now because all we wanted was the slope. And this means that m equals 1/2. So, now that we know the slope, everything's easy, right? The slope is 1/2. So we can write 1/2, and then we just use what's given. We know that the point 40 is on the line. So we plug 4 in for x. We don't know what b is yet. B is our unknown. And in this case, we know that y is 0. Well, this is 2, so it seems to me that b must be minus 2, right? That way, this will turn out to be 0. We have 2 plus a minus 2. So, our line, parallel to this line, passing through the point 40, is 1/2 x minus 2. See? Pretty easy. Well, I mean, if you did it, it would be easy. When I do it, I make double arithmetic mistakes, I confuse myself, and I hope you guys get a good laugh watching me trip over my own feet. Now all we have to do is figure out which one of these equations would be the equation of the line that passes through these 2 points. Oh, sorry. It just has to be parallel to these 2 points. And you might think, gee, that sounds kind of tough. I mean, there's an infinite number of lines parallel to any particular line. How do we figure out which one of these it would be? Well, they're not asking you to find one exact. They're just asking you to find one that could be. Which one would potentially work? And what do we know about parallel lines? If we have equations for a line, what is it that tells us they're parallel? It's the slope, right? So what's the slope here? We get 9 minus 1. Oops. 9 minus 1 over 2 minus a minus 2. And I think that's 8 over 4, which is 2. This is the one with the slope equal to 2. I don't see. That's 1/2 minus 1/2 minus 2. And unless I got a minus sign wrong, this is it. Let's see here. 9 minus 1 is 8. 2 minus minus 2 is 4. Yes. So, boom, you're done. All you had to do was figure out what the slope was. It sounds more complicated than it is. And once you found the slope, you just had to find one with this number in front of an x, to put it in simple terms. Remember, the slope is just the part in front of the x. So, just find one with a 2 in front of the x and you're all done. Here's one very similar to what we did when we were finding an equation for a line parallel to a given line. Now we want one that's perpendicular to the given line, but passes through a particular point. What do we need to do? You could solve for y, put it in Slope-Intercept Formula, and that'll give you the slope of the line, and then you take the slope of the perpendicular line. But we already know the slope of this line. It's the part in front of the x. if you factor this out, it'd be minus 2x minus 6. But who cares? None of the rest of this stuff is relevant. All we need is the slope. If there was some number in front of the y here, we'd have to do some division to get the actual slope. But it's just a plain y on this side. So we already know our slope. It's minus 2. But we want a line perpendicular. So this is the slope. We'll say that equals m. But what's the perpendicular slope? Well, that's the negative reciprocal, so that's just 1/2, right? Flip it, and then change the sign. So our perpendicular slope is 1/2. So the equation for our line perpendicular to this line and passing through this point would have to be 1/2 x. So let's just plug in an x there so we can get to our b. Plus b, and we know that equals 3 because 3 is on the line. See, the point 23 is on the line. That means we can put 2 in here for x and 3 in here for y, and that gives us, well, 1 plus b equals 3. I'd vote for 2. So the equation for the line here is y equals 1/2 x plus 2. Pretty much exactly what we did when we were finding lines parallel to another line through a given point. First you find the slope, and then you work out what b must be by plugging in the values that you're given here. See, when you're given a point, that's really exactly the same as saying that x equals 2 and y equals 3. That's why we were able to plug them in over here. And that's always true. When you're given a point like this, what you're really saying is x equals 2 and y equals 3. You can think of it as the point 2, 3, or you can think of it this way here. Now here we're asked to graph an equation that's laid out algebraically, kind of simple, but it's not that easy to see how to plot points. I guess you could. You start, put in a 0 for here and see what you get for x, or vice versa. That's one way. Or what I usually do, or you can get some software and just plug this in, but that's cheating. We'll use the software later on so as to not waste time. But you need to know how to do it first. It's kind of like a calculator. It's cool to use a calculator, but you should know how to add and subtract first, and then let the calculator help you. So this one is pretty easy. We're going to get 2y. We'll do it step at a time, though, since I have a habit of making really dumb mistakes. Equals minus 10, minus 8x on each side, so that's minus 8x. And then we divide through by 2 and get that y equals minus 5 minus 4x. Did I make any dumb mistakes? Probably, but I don't see any. So we'll stick with this. And our job is to graph this. Doesn't seem too hard. Let's see here. What do we get? When x equals 0, we're down here at minus 5, aren't we? When x is minus 1, that's minus 5 plus 4. That's up here, isn't it? When x is minus 2, we get 8 minus 5. That's 3. Notice I started using negative numbers because it's easier. If I went over here to 1, then I get minus 5 minus 4. That's going to be way down here at minus 9. And my third point is going to be right off the graph because I'm only going from 0 to 9 vertically. So I did it this way. It's legal. Do it either way you want, as long as you get... After all, we're only graphing a line, so I only needed 2 points. I did one more point just to see if I was on the right track. See if they all lie in a straight line, and they seem to me. So wonder why I have such trouble with steep lines. It's because my graphics tablet is at an angle. It's not flat on the desk. I keep it up so it's similar to the angle of the screen that I'm writing on. My tiny brain makes the juxtaposition easier that way. But it makes it hard to draw really steep lines because I'm really going up and down and not sideways. Who cares? Now you know why my graphics look so bad. The point is, all you had to do was put this into a form that's a little bit easier to use, and then plug some numbers in. I used 0, -1, and -2. You could have used something else. Whatever works for you and makes it easy. Whatever makes it easy, that's the right way to do it. Unless your instructor tells you something else, and then I'm wrong. Now here's one where the, well, we'll say the dopey guy who makes geometry videos made this horrendous mistake. In fact, I actually did this a few problems back, didn't I? Jeepers. That's embarrassing. I am the textbook example of making mistakes. Define the X-intercept, set X equal to 0. No. Of course not. You set Y equal to 0. And then solve the equation. And for the Y-intercept, you set X equal to 0. Why would that be true? Well, there's the Y-axis, there's the X-axis. When X is equal to 0, you're right here. And that, when X is 0, there's the Y-intercept. When Y is 0, well, there's the X-intercept. And just for the fun of it, what would the intercepts be? Well, remember the first thing you do is just try to get everything out of one side. So add 3y over here, put it over there. We'll add 15 over here. And we've got 5x over here. Okay, that seems all right so far. So now what do we get? Y equals 5 over 3. X plus 5. So Y-intercept is 5. Which is what he got for the X-intercept. Not too surprising considering that dopey guy who makes videos reversed the two. And given this equation, now that we've got written out like this, to get the X-intercept, all we do is set Y equal to 0, and we would write 0 equals 5 over 3x plus 5, or 5/3 x equals -5. Multiply by 3/5 on each side, and we get minus. I'm sorry. Well, I think I said it right and then wrote it wrong. Let's see here. Multiply, I probably said it wrong too. Multiply through by 3/5. That'll cancel out the -5. And we get -3 over here. So, when y equals 0, we cross the x-axis at -3. So, by analyzing this closely, you can learn, once again, from somebody else's mistakes. Very good way to do things. Now, here we have several equations for a line. The question is, which one of these are parallel? Once again, we just need to know the slope. one of the steps in finding the slope will be to divide through by the coefficient of y. For instance, the slope in this one, we're going to get everything over here and multiply, so let's do it. We got to turn this coefficient of y into a 1. So what do? We divide through by minus 6. So here the slope is minus 1 over 6. That's what's going to happen when you divide through by minus 6. Here we divide through by minus 1, which gives us a slope of minus 6. Here we divide through by 6. And that gives us 1 over 6. Now let's try it the long way, because what we got here is none of these lines are parallel. Let's work it all out the long way. Our equation over here would be minus 6y equals 10 minus x. Divide through by minus 6 and we get y equals 10 over minus 6. Minus 1 over minus 6 x. And that gives us that y equals 16x minus 4 over 3. So, I see a difference between these two. Don't you? What was the difference? Well, we had to move this over here, didn't we? To get it in y. And then multiply through by minus 6, but that made the coefficient for x minus 1, and that made everything positive. So what we get here is a slope of 1 over 6. So, shortcuts are cool, but they can mess you up, just like I just got messed up. Over here, I probably did it wrong over here too. Let's try this one the long way. Now we got minus y equals 11 minus 6x. We multiply through by minus 1. And what do we get? Y equals 6x minus 11. Well, another dumb mistake. There we go. That's actually supposed to be a plus 6, isn't it? Why? Well, like I said, we move it over, get all the signs right, and we end up with positive 1 down here. This one here, well, let's find out. I don't trust anything anymore. Let's say 6y equals 12 minus x. I divide through by 6 and get that y equals 2 minus 16x. So, see the bonehead mistakes I made? This is supposed to be positive 16. This is supposed to be negative 16. And this is just 6. So, it turns out, by extreme luck, none of these are parallel. And that's all it is. I made so many mistakes doing this. I had no right to be correct. So the moral of this story is, be real careful with your shortcuts. They can lead to trouble. It's supposed to be a 6. And I used a wind plot here to plot each of these. If you do this, notice when you down here it says implicit. That's the same as standard. And that's how I wrote them, x minus 6y. I just wrote them the same way I think they were given in the previous problem. Anyway, I think it's pretty obvious that none of these lines are parallel. And if you're wondering about the different colors, where this equation is written in red because the line is graphed in red. This one is blue, and the line is in blue. This one's green, and the line is in green. And this is using wind plot. I've mentioned it before. Heck, you can Google it. I think there's a university website. The professor at that university created this. He offers it for free. It loads up in it installs, in just a couple of seconds. It takes practically nothing. There's hardly anything to it, and yet it works very well. And what we're asked to do here is to find the equation of this line. And we're going to have to use the diagram, because they don't tell us anything, they just give us a picture. So let's figure out, what do you think this point here is? Well, that looks like the y-intercept to me. And in most equations, the y-intercept is written as b, right? And that's 1, 2, 3, I'd say it's 4. The x-intercept, if we need it, is 1, 2, 3, 4. Well, Now, the equation for this line, let's see here. We go down one and across one. We go down one and across one. Down one. Ooh, well, it looks to me like the rise over the run is minus 1 over 1. So, what do we have? Y equals mx. Mx is, of course, minus 1 times x. Plus 4. Or just minus x plus 4. Very easy. Here they ask us how many solutions these two equations share. Remember, sharing a solution means in a sense they intersect. The two lines intersect. It means they're looking for points x and y which solve these equations. So how would we do that? If we wanted to do it algebraically, how would we figure it out? Well, let's put this into our standard slope-intercept form. Now if we do that, we can put a y over here, subtract 1 from each side, and get that y equals 4x minus 1. Up here, we have that y equals 4x minus 9. So we'll set those two equal and see what kind of solutions we get. That was 4x plus 9. Well, what we can do is subtract 4x from each side and get that minus 1 equals 9. That can't happen, which means there is no place where these two lines would intersect. There is no solution to what solutions do these two equations share? The answer is none. And let's see if I can, let's see here. Well, here's where I just went ahead and graphed the two lines. And as you can see is, should be able to move up and down. There we go. Wow. Now, graphically, it certainly looks like there we go. Graphically, it looks like these two lines are not going to intersect. And that makes sense, because, there we go. We determined algebraically that setting these two equal makes no sense. There is no point at which both of these equations can hold. And we can see that from the fact that the two lines turn out to be parallel. Normally, when you have two equations over a line, what's going to happen is this. They can be parallel like they were before, or they will intersect, in which case, when you set up this equation, your solution will be 1 point, x1 comma y1, or yeah, guys just say xy, I guess. It'll just be 1 point here, and I think we showed that earlier. One of our postulates that two lines intersect in only 1 point. Well, remember, when you have an equation for a line, every point on this line is just a solution to that equation. That's what it means when you graph this line. And every point on this line is a solution to the other equation. Where do the solutions cross? At only 1 point. For two distinct lines. Just one other possibility. We've got a line here, and we got another line right on top of it. In other words, they're exactly the same line. So if I were to write y equals 6x, 6x plus 4, or I wrote if I wrote this equation and asked for the common solutions, well, they're either going to be none, 1, or infinity. 1 when they intersect, none if they're parallel, and an infinite number if they turn out to be exactly the same line, which is what this will be. If I solve this equation here, I'll get 2y equals 8 plus 12x, and that'll mean y equals 6x plus 4, same line, so we have an infinite number of common solutions. Most of the time, I mean, if you just, well, think of a long nail, like a 3-inch nail. That's a straight line, right? I'll drop a 3-inch nail, and then drop another 3-inch nail. What's going to happen most often? Well, I suppose once every billion years or so, that second nail just lie right on top of the first one. And a little more often, but still hardly ever, they'll land parallel. And most of the time, they won't be parallel. They'll cross each other. So, parallel lines, no solutions. Coincident lines, same line, infinite number of solutions. And most of the time, two distinct equations give you one common solution, the point where the lines intersect. Okay, well, I guess we've had a lot of fun with slopes in the last two